In this video, I'm going to do a bunch of example slope problems. And just as a bit of review, slope is just a way of measuring the inclination of a line. And the definition, we're going to hopefully get a good working knowledge of it in this video. The definition of it is change in y divided by change in x. And this may or may not make some sense to you right now, but as we do more and more examples, I think it'll make a good amount of sense. Let's do this first line right here, line A. Let's figure out its slope. And they've actually drawn 2 points here that we can use as the reference points. So first of all, let's look at the coordinates of those points. So you have this point right here. What's its coordinates? Its x coordinate is 3, and its y coordinate is 6. And then down here, this point's x coordinate is -1, and its y coordinate is -6. So there's a couple of ways we can think about slope. One is we could look at it straight up using the formula. We could say change in y. So slope is change in y over change in x. And we can figure it out numerically. And I'll, in a second, draw it graphically. So what's our change in y? Our change in y is literally how much did our y values change going from this point to that point. So how much did our y values change? Our y went from here. Y is at -6. And it went all the way up to +6. So what's this distance right here? Well, it's going to be your endpoint y value. It's going to be 6 minus your starting point y value, minus -6, or 6 plus 6, which is equal to 12. And you could just count this. You say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So when we changed our y value by 12, we had to change our x value by, what was our change in x over this same change in y? Well, we went from x is equal to -1 to x is equal to 3. Right? X went from -1 to 3. So we do the endpoint, which is 3, minus the starting point, which is -1, which is equal to 4. So our change in y over change in x is equal to 12 over 4. Or if we want to write this in simplest form, this is the same thing as 3. Now, the interpretation of this means that for every one we move over, we could view this, let me write it this way. Change in y over change in x is equal to, we could say it's 3, or we could say it's 3 over 1. Which tells us that for every one we move in the positive x direction, we're going to move up 3, because this is a positive 3, in the y direction. You can see that. When we moved 1 in the x, we moved up 3 in the y. When we moved 1 in the x, we moved up 3 in the y. If you move 2 in the x direction, you're going to move 6 in the y. 6 over 2 is the same thing as 3. So this 3 tells us how quickly do we go up as we increase x. Let's do the same thing for the second line on this graph. Graph B. Same idea. And I'm going to use the points that they gave us. But really, you could use any points on that line. So let's see. We have one point here, which is the point 0, 1. You have 0, 1. And then the starting point, we could call this the finish point. The starting point right here, we could view it as, let's see, x is -6, and y is -2. So same idea. What is the change in y given some change in x? And so let's do the change in x first. So what is our change in x? So in this situation, what is our change in x? Delta x, we could even count it. It's 1, 2, 3, 4, 5, 6. It's going to be 6. But if you wouldn't have a graph to count from, you could literally take your finishing x position. So it's 0, and subtract from that your starting x position. 0 minus -6. So when your change in x is equal to, so this will be 6, what is our change in y? And remember, we're taking this as our finishing position. That's our finishing position. This is our starting position. So we took 0 minus -6. So then on the y, we have to do 1 minus -2. 1 minus -2. So what's 1 minus -2? That's the same thing as 1 plus 2. That is equal to 3. So it is 3/6 or 1/2. So notice, when we moved in the x direction, by 6, we moved in the y direction by positive 3. So our change in y was 3 when our change in x was 6. Now, one of the things that confuses a lot of people is how do I know what order how did I know to do the 0 first and the negative 6 second, and then the 1 first and then the negative 2 second? And the answer is you could have done it in either order as long as you keep them straight. So you could have also have done change in y over change in x. We could have said it's equal to negative 2 minus 1. So negative 2 minus 1. So we're using this coordinate first. Negative 2 minus 1 for the y over negative 6 minus 0. Notice this is the negative of that. That is the negative of that. But since we have a negative over a negative, they're going to cancel out. So this is going to be equal to negative 3 over negative 6. The negatives cancel out. This is also equal to 1/2. So the important thing is if you use this x coordinate, if you use this y coordinate first, so we use this y coordinate first, then you have to use this x coordinate first as well. If you use this y coordinate first, as we did here, then you have to use this x coordinate first, as you did there. You just have to make sure that your change in x and change in y are you're using the same final and starting points. And just to interpret this, what's this is saying? This is saying that for every minus 6 we go in x, so if we go minus 6 in x, so that's going backwards, we're going to go minus 3 in y. Minus 3 in y. But they're essentially saying the same thing. The slope of this line is 1/2, which tells us for every 2 we travel in x, we go up 1 in y. Or if we go back 2 in x, we go down 1 in y. That's what 1/2 slope tells us. And notice, the line with the 1/2 slope, it is less steep than the line with a slope of 3. Let's do a couple of more of these. So let's do this line C right here. I'll do it in pink. And let's say that the starting point, I'm just picking this arbitrarily. I'm using these points that they've drawn here. The starting point is at the coordinate negative 1, 6. And that my finishing point is at the point, what is this, 5, negative 6. 5, negative 6. So we could do, our slope is going to be, let me write this. Slope is going to be equal to change in x, change in y. I'll never forget that. Change in y over change in x. Sometimes it said rise over run. Run is how much you're moving in the horizontal direction. Rise is how much you're moving in the vertical direction. And then we could say our change in y is our finishing y point minus our starting y point. Right? This is our finishing y point. That's our starting y point over our finishing x point minus our starting x point. And if that confuses you, all I'm saying is it's going to be equal to our finishing y point is negative 6 minus our starting y point, which is 6, over our finishing x point, which is 5, minus our starting x point, which is negative 1. So this is equal to negative 6 minus 6 is negative 12. 5 minus negative 1, that is 6. So negative 12 over 6, that's the same thing as negative 2. And notice, we have a negative slope here. Negative slope. That's because every time we increase x by 1, we go down in the y direction. So this is a downward sloping line. It's going from the top left to the bottom right. As x increases, the y decreases. And that's why we got a negative slope. This line over here should have a positive slope. Let's verify it. So I'll use the same points that they use right over there. So this is line D. Slope is equal to rise over run. Now, how much do we rise when we go from that point to that point? Well, let's see. We could do it this way. We are rising. I could just count it out. We are rising 1, 2, 3, 4, 5, 6. We are rising 6. And how much are we running? We are running, I'll do it in a different color. We're running 1, 2, 3, 4, 5, 6. We're running 6. So our slope is 6 over 6, which is 1, which tells us that every time we move 1 in the x direction, positive 1 in the x direction, we go positive 1 in the y direction. So this is for every x, if we go -2 in the x direction, we're going to go -2 in the y direction. So whatever we do in x, we're going to do the same thing in y in this slope. And notice that was pretty easy. If we wanted to do it mathematically, we could figure out this coordinate right there that we could view as our starting position. Our starting position is, see, -2, -4, -2, -4. And our finishing position is 4, 2. 4, 2. And so our slope, change in y over change in x, I'll take this point, 2 minus -4, 2 minus -4, over 4 minus -2. 4 minus -2. 2 minus -4 is 6. And remember, that was just this distance right there. And then 4 minus -2, that's also 6. That's that distance right there. And we get a slope of 1. Let's do another one. Let's do another couple. And these are interesting. Let's do the line E right here. So change in y over change in x. So our change in y, when we go from this point to this point, I'll just count it out. It's 1, 2, 3, 4, 5, 6, 7, 8. It's 8. Or you could even take this y coordinate 2. This y coordinate 2 minus -6 will give you that distance, 8. And then what's the change in y? Well, the y value here is, what's the change in x? The x value here is 4. The x value there is 4. X does not change, so it's 8 over 0. Well, we don't know. 8 over 0 is undefined. So in this situation, the slope is undefined. When you have a vertical line, you say your slope is undefined, because you're dividing by 0. But that tells you that you're dealing probably with a vertical line. Now, finally, let's just do this one. This seems like a pretty straight up vanilla slope problem right there. You have that point right there, which is the point 3, 1. So this is line F. You have the point 3, 1. And then over here, you have the point -6, -2. So our slope would be equal to change in y. I'll take this as our ending point, just so you can go in different directions. So our change in y, so now we're going to go down in that direction. So it's -2 minus 1. That's what this distance is right here. -2 minus 1, which is equal to -3. Notice we went down 3. And then what is going to be our change in x? Well, we're going to go back that amount. What is that amount? Well, that is going to be, let's see, it's going to be -6. That's our endpoint, minus 3. -6 minus 3. That gives us that distance, which is -9. So for every time we go back 9, we're going to go down 3. If we go back 9, we're going to go down 3, which is the same thing as if we go forward 9, we're going to go up 3. All equivalent. And we see these cancel out, and you get a slope of 1/3. Positive 1/3. It's an upward sloping line. Every time we run 3, we rise 1. Every time we run 3, we rise 1. Anyway, hopefully that was a good review of slope for you.